When scientists conduct experiments, they collect their data in tables often, and sometimes they want that data to be modeled by a linear function. So they have to find a function that fits their table. Let's see how we could do that. So we've got this table here. We want to find a linear function that could describe it or match this information. And when we're talking about linear functions, we like to think of our slope-intercept form, right? mx plus b. M is our slope, and b is our y-intercept. So if we want a linear function, we got to find the slope and the y-intercept, and then we're done. Let's do that. So we'll start with the slope. Slope, remember, is rise over run, or change in y over change in x. So the y values are the f of x column, the x values are the x column. Rise, we're going from 4 to 7. So 7 minus 4 is how much we're lifting up. And then the run, the change in x, it's 1 minus 0. 7 minus 4 is 3 over 1. That gives us a slope of 3. The next thing we need, the last thing we need, is the y-intercept. So if we want the y-intercept, remember this is the point on the graph where the x-coordinate is 0. But when we say the x-coordinate is 0, we mean that the input of our function is 0, f of 0. If we're looking for f of 0, well, fortunately for us, x equals 0 is already listed in our table. So input 0, the output is 4. So slope 3, y-intercept 4, this means that f, our formula for f of x, is given by 3 times x plus 4. 3x plus 4. And that's the answer. And this, if you plug in x equals 0, we get 4 back. If you plug in x equals 1, we get 7. So that does match this data. Let's try a more interesting example. So let's look at this table for the other function g of x. So this one's going to be a little bit more interesting, but the same principles apply. So we start with the slope. So change in y over change in x. So the change in the y values, we're going from -1, or from 3 down to -1. And change in x, going from 5 up to 7. -1 minus 3 is -4. 7 minus 5 is +2. And then we divide, we end up with -2. So our slope here is -2. And now we want the y-intercept. So that's going to be g of 0. All right, well, we look at our table, and here's the problem. We don't have a 0 in our x column, so we're going to have to work to get g of 0. But we can use the information in this table to get there. So we know that we're saying that g of x equals mx plus b. Slope times x plus our y-intercept. And we know that the slope is -2. So g of x equals -2 times x plus b. And so now we have to get rid of this b, or we figure out what this b means. And we can use any row in this table. So if we just take any, let's take the first row to be simple. So we just replace x by 5. And this is going to be a true statement, and it'll tell us what g is. So let's look at g of 5. G of 5 equals -2 times 5 plus b. And so there we simplify. We know that g of 5 is 3 because that's what the table tells us. So this is 3. -2 times 5 is -10 plus b. If we add 10 to both sides, that gives us b equals 13. And so we combine our slope -2 with our y-intercept 13, and we get g of x equals negative 2x plus 13. And if you compare this with our table, you're going to see that that all matches.